In this next example, we look at surveying 5 PCC students and we ask, is this your first year here? And we've found that 20% of all PCC students are in their first year. And with that information, what is the probability that all 5 students that we ask are new? In other words, are in their first year. So this is really a binomial problem here, where we have a 20% probability of success. We're asking 5 students, so we're doing the experiment 5 times with a number n equals 5 is the number of trials. And because here we're looking for all 5 students to be successes, right? We're going to have our x that we're looking for is 5. So in our binom PDF formula, we can kind of list out those values that we just mentioned. We have P, our probability of success, was 0.20. Number of trials, we had 5 students that we were asking. And X, the total number of successes that we're thinking for, or looking for, is also 5. So we want all 5 of them to be successes. And in this case, this would really just be the same as, because we actually know here that these are all independent trials, there's only one way for all 5 of them to be successes. So we can just use the multiplication rule. Just do 0.20 to the power of 5, which would give me 0.00032. Notice that because this is a binomial problem, we can also use the binom PDF function, and it should give you the same result. So binom PDF, we had 20 trials, or sorry, I take that back, we had 5 trials. So let's fix that. Five trials, 0.20 was the probability of success, and we were looking for 5 successes. And that should give you the same result that we got there. In the next example, what is the probability that 2 or 3 will be new? So in this case, we can compute 2 probabilities. We want to get the probability that exactly 2 are new, and then add that with the probability that exactly 3 are new. So here, 2 or 3, we're using our addition rule. And so we can actually use here our binom PDF formula. So we'll have the binom PDF, 5 trials, 0.20 probability of success, and the first one we're looking for 2 successes, plus for the next one, the binom PDF, 5 trials, 0.20 probability of success, and we're looking for 3 successes. 3 successes. So when we compute each of those, we get 0.2048 for 2 successes, and then 0.0512 for 3 successes, and then combining them together, we get a probability of 0.256. Part C, what is the probability that at least 1 will be new? Now again, here we can use the complement like we've done in other cases where we see this probability of at least 1, right? So that would be the probability of 1, 2, 3, 4, or 5. So perhaps an easier way to answer this would be to do the complement. 1 minus the probability that exactly 0 were successes. And actually here we know that in this case, because these are independent trials, that 0.80 would be our probability of failure. And so if all 0 of them, or sorry, all 5 of them were failures, then we have 0.80 to the power of 5 probability of that occurring. So 1 minus 0.80 to the power of 5 would be about 0.672. Now let's fill in our probability distribution, and we've got a couple of these already. We can fill in some of them that we haven't found yet. Notice that in part A, we actually found the probability of 5 successes, so that was 0.00032. In part B, we found the probability of 2 and 3. So we can use those two results that we found there. And let's see, in part, well, actually that just leaves a couple that we haven't found yet. In part C, we found the complement of x greater than or equal to 1, which involved 1 minus the probability that x is equal to 0. And if we did that, 0.80 to the power of 5 would give us something around 0.32768. And then we just kind of have to work out a couple of these separately. For instance, here we could do the binom PDF, 5.20 and 1 to get that one. And then here we could do binom PDF of 5.20 and 4. So let's see, here that would give me 0.4096, and here that would give me 0.0064. And okay, now that I have my whole distribution, we can look at a graph of that data, or the graph of those probabilities here. So we'll graph each of the p of x values here on the graph. So for instance, we have a probability of 0.32768 when it's 0. So here, let's see, when it's 0, maybe just a little bit more than 0.3. When it's 1, we have 0.4096, so maybe just a little bit more than 0.4. Let's see, when it's 2, we have a probability of 0.2048, so maybe just a little bit more than 0.2 there. When it's when it's 3, we have a probability of 0.0512, so we'll maybe put that maybe a little bit higher than halfway there. And then let's see, the other ones are going to be really tiny. So 0.0064, that's going to be really tiny, really close to the bottom. And then 0.0032 is basically just barely above 0. So you can see there at each of those different values of x, we have their probabilities graphed here, and we can see their heights as probabilities. So in the next question, they ask, if we surveyed 200 students and I asked the probability that between 113 and 187 students are new, how would you find your answers? So actually in this case, this would be a lot of work to compute by hand or using the PDF formula, because this would involve doing each of these separately. The probability that exactly 113 plus the probability that exactly 114 plus the probability of 115, and so on, all the way out to the probability that exactly 187 were new. So that would take a long time because that's a lot of values to compute with the formula. But luckily we can use the cumulative distribution formula or the cumulative distribution function on our calculator to do that for us very rapidly.